Okay. We are live for Advent Code Day 16. I think this might be when it starts to get really hard, going by previous years. Mm. Um, okay, we got about 20 minutes until the problem drops. I'm going to do a bit of cleanup as my warm-up. Cleanup at day 14. Day 15, we could pull that up real quick. Oh, there's not much to say about this one. This was a fairly straightforward. The implementation was fairly straightforward. I think 15 was more of a reading challenge than anything else. Yeah, let's go here. I finished this one last night just before day 15 came out, 5 minutes to spare. And I was pretty hacky about it. There's a lot I can be deleted. Let's start by not deleting the tests quite yet. Well, let's keep track of a few tests that might be really nice. I guess these would be nice here. This will work. This is what we'll check against. If there's anything else. I guess the answers, these cycles, it's more for the example input though. Okay, so all of these can be one function. That's just generic based on the direction that's passed in. So what do we say? This is like open area. Open area. So def, and then as a dir parameter. Okay, this area's not flat in here. This can be just a flat map. And it doesn't need to be, excuse me, it doesn't need to be a val anymore. Yeah, and now val area south is just open area, dir.south. I'm still making these vals because I want these maps to be cached. All right. All right. It's looking better. This roll method is not needed at all. This roll all could probably use a few simplifications. Um, okay, for one, like these moving points here are not necessary. This can just be, we could inline that and then do dot count. Count start. Instead of doing intersect start size, so count how many are in the starting set. Okay, so we can do that refactor to all of these. At some point, I'll probably just make this whole thing generic too, but it seems a little bit trickier because there are two places. Okay, I think I'll try something like this. So ac union set that from. Yes, exactly that. So we don't really need that variable and we don't need this. Okay. Let's do that same refactor. Ac union set that from, yada yada. It knows what I want. Hopefully this is looking a little bit easier to generalize. Hmm. This is always going to be like opposite of the direction. In some cases, this should be like an empty iterator, specifically when this moving count is 0. Because this be 2 p dot y minus s, it'd be like to itself. Da, da, da. We could try like using my line object between those. No, I'm not completely sure yet about that. Let's do some other cleanup. Showing rounded, sure. So def cycle, load. I don't think we need this particular iteration of those tests. Hmm. Hmm. Okay, let's try to simplify this cycle calculation. There might be things we don't need. I don't like, here, this collect first. I think I want to turn that into an index where somehow hash zip with index. We zip with index so that we can check hashes of that size as a way of checking if the hash is contained in the scene hashes. While we do this, scene hashes zip hashes and an index where scene hash, sure. And then this would be like our repeat. And we could just use that here instead. Hmm. And you know what? Honestly, this is simple enough. I should just inline this. So this is going to be like the first, this is going to be the repeat index, first index, a repeated cycle. We can just do hashes.index where it is just cycles, repeat. Or wait, the hash of that. Hold on, what was it formerly? The hash code. Oh, we get the hash code of the repeated cycle. We can just take the index. Yeah, so equals hashes repeat. There. That's so much simpler. Okay, and cycle length is just repeat minus first. Maybe I'll call this a period. Okay. And then this is the congruent index. We'll just rewrite this. Was almost. Need to add first to the start. Okay, let's see if we still get the right answer. That looks correct. Let me verify. What was that? Day 14. No, my puzzle was 93102. Oh man, at what point did that change? Repeat minus first. This is wrong. Hmm. Okay, let me see. let's look at the example. And then look at things like this. Okay, those look correct. So we'll go with that. It's somewhere in our cycle calculation. So let's see what we changed. We find the repeated cycle by looking at the repeat index, and we get the hash code of that. And we compare it to hashes index where, yeah. Why is repeat so low? Why is it 2? Index where, do I have to do like a from? This is the first time where a hash that we compute has actually already been seen. Is it because like, no, the first two can't have the same hash? I mean, I guess, you could write a case where that was the case and it would mess with my calculations. Okay, we had the first three, and yeah, the second and the third share the same hash code. Why is that? Do they actually look the same? So let's say, let's do this. Oh, what's going on? I think we're still down here. Okay, so cycles 0 equals cycles 1. Cycles 1 equals cycles 2. Okay, let's look at these three. That's looking wrong to me. Okay, so there is a mistake in here somewhere. Ah, okay, I think I see what it might be. So west, p dot east dot x, sure, plus moving count, p dot n. I think this should be minus here. Minus moving count by -1. This should be plus moving count. You know what? Before we actually change that, let's just look at what it changed from. Yeah, it is minus. Copilot, you betrayed me. Your autocomplete didn't actually give me what I want. Okay. Okay, that's better. And let's look at this. So is PEX plus moving count? Sure. And this one here. PW minus moving count by -1. Okay, I think that was the only one that's problematic. Don't need these. So why don't we show like moving it north? So roll all rounded to north. You know what that should look like? Oh, okay, there's a problem there. Right there. Very, very obvious. Oh, hold on, hold on. This autocomplete isn't good either. Okay, so that should fix that. That looks correct now. ANS2 is still incorrect. Let's show pushing it in various directions. North, west, south, and east. Okay, you push west, and we're missing pieces. Okay, north is the only one that's correct, because there should be 18 pieces, right? Um, okay. Oh, hold on. Go. Okay, this should all be 18. So moving west is problematic. Let's move it like moving west. So north. Wait, south was also problematic, right? South is fine. South is fine. It's just west and east. Okay, west and east. So P dot pushing north is pushing in a negative direction. It's much like pushing west. So we'll put that first. So these should look similar. P dot x plus moving count. P dot y. Area east. Are these calculations fine? I hope so. Right, this is, I'll just put them in the same order here. Northwest, south. Okay. Mhm. South is fine. West is problematic in that a lot of things disappear. Why don't we show each of these as we're doing it? So we look at the area to the east. We're pushing west. So we look at the area to the east of that rock, right? And for each of those areas, yes, the idea to rotate was, this is what I wanted to avoid. But this is what we have, so this is what I'm cleaning up. I think I'm gonna add that to my library code at some point, just so I don't have to do the math in the heat of the moment. Like, it already rotates, but it only rotates around 0, 0. I need it to rotate around any point, including points in between. So I will figure that out. Um, we look at each of these areas. Well, let's just do some printing. Print line, moving count, and then we'll like print line the area, just the area. We could give this a value and then show it. We'll just call it x. And then print line x followed by, we are almost running out of time. Okay, let's look at what happens down here. Okay, so we're moving 0. Here is the range. Nothing gets moved. We're moving 3. Here's the range. It gets moved to 2, -1. Those are not good points. So 1, 1, 1 to 1. So we stay 1 on the x. Makes sense since we're moving west. And then range 0 to 9. So this should be, the x should stay the same, but the x is moving. Okay, let's take a look at that. I mean, okay, yeah, the x should move. X should move. Well, what was wrong? So the x 2, 3, 4, yeah. the y value is wrong. The y value is -1. Okay. Um, and west. B dot y. That's a point where the rock is. Print line. We'll just print that point. Okay, you know what? I'm out of time. We can do this later. So day 16. Pull that up. Let's go back to the calendar. We have 35 seconds left. Okay, yeah, that should fail right now. Good morning, Blue. Let's sort join for the tilt operation. You know, if I was using a grid, it's very easy to rotate that, but I was using a set of points, which I think for that problem was a mistake. Floor will be lava. Ooh, cool, cool, cool. Another grid problem. Okay, lava production facility. Bright light in a cavern up ahead. Flat two-dimensional square grid containing empty spaces and mirrors and splitters. Okay. Most of the beams bounce around the grid. Each tile converts some of the beam's light into heat, not the rock in the cavern. Okay, so I think we need to calculate the heat on each point, maybe? You know the layout of the contraption. So the beam enters in the top left corner, moves to the right, then its behavior depends on. So if the beam encounters an empty space, it continues in the same direction. A mirror is reflected 90 degrees, makes sense. A pointy end of a splitter. The beam passes through the splitter as a splitter empty space. Okay. If the beam encounters a flat side of a splitter, the beam is split into two beams going in each of two directions. Splitter's pointy ends are okay, yes, yeah. For instance, blah blah blah. Okay, that makes sense. So this one gets split, goes down, gets split, passes through, gets rotate, whatever. And they're putting twos there. Beams are only shown on empty tiles. Arrows indicate the direction of the beam. Okay. If a tile contains beams moving in multiple directions, a number of distinct directions is shown instead. And this shows which tiles are energized. This is the number of tiles that become energized. The light isn't energizing enough tiles to produce lava. To debug this contraption, you need to start by analyzing how many tiles currently end up being energized. Okay. Get line stuff to list. Or, you know what, to vector, because this is a grid. Import my AOC stuff. And we'll take an area. And this only has the mirrors, right? Okay. So go back there. Well, mirrors, this is a map from point to just a car. Yeah. Knows my standards at this point. Not equal to that, sure. Okay. And the beam always enters from the top left. So def beam path. Okay, we could make this like a recursive function, right? Whenever we hit something, then we just recursively call. So path. So from point and a direction and an iterator point. And this is a good start. So take while. And then we're gonna do another take while on top of this. And we also want to get that character. We're gonna do like a find. Oh, Meaty Chode, thank you. Advent of Code. What is Advent of Code? It is a bunch of small programming puzzles that appear in a calendar in December. You should check the website, adventofcode.com. uh, okay. So that's the first start of the path. We can find, we can do a take while. Take while, not mirror if that contains that point. And then, in fact, we're going to do like a span. And we'll have like energized tiles, energized, and then the remaining path forward, and continue. So we'll call it energized and continue. And then we take the size. So I don't want to return an iterator. I think I want to just return a set of points. So val energized. Sure. Good explanation, Blue. And then mirrors. So continue dot next, I guess next option. Yeah. So if there's nothing, we just return that energized set. Otherwise, we match on its contents. In fact, you know what we're going to do next option, fold with just energized set. And then we're going to take C, or you know, just whatever it is, we're just going to take it and match. And then we want the mirror at that point. Mirrors at that point. The case. Oh, wait, did it know? Okay, it sorta knows. So our directions, we can rotate them. We'll do this. Oh, hold on. Next option, that fold. Wait, what's parameter? It's just gonna be a point to B to my set. So that should be fine. Fine syntax. What issue does it have with it? I don't know. Let's just do this. Or P to, oh, you know what? I think it has to be on its own line. And then we'll do like mirrors P dot match. And I don't like this code that's given me. So, this effect here depends on the direction. I want to make this more programmatic. So I'm going to match this. Well, okay, I'm just going to match this with the direction that we're moving. So if we have this kind of mirror, then whether it's coming from east or west, so we're going to do like a dir.east or dir.west, then it's going to be whatever our direction is, and we're going to make a left turn, right? So path, yeah, so we're going to take our energized sets and add it to a recursive call to path. So p dot move is not going to be direction dot north. I guess my from includes the point. I think it'd be more convenient if my from point came from outside. So that's what I'll do. I'm going to do like a drop one here. Drop one. How did it know that's what I wanted to add? It has an syntax issue with this, and I don't know. I will figure out here eventually. So path, we do from that p, and then dir dot turn right. And then now if it's dir dot north or dir dot south, we wait, if we're going, no. If we're coming in from the east, we turn left. If we're coming from the west, we turn left. So this is turn left up here. Turn left. Well, if it's north or south, then we turn right. Okay. Now we have a case. This vertical pipe, if we're from the north or south, oh, we should ignore it. I think I could still do this like recursively because we only want the tiles in the ground, right? So we don't want to count that as one of our tiles that are energized. And then dir dot north or dir dot south. Then we take their energized set, union path, p dir. Yes, exactly. We continue. And then if it's east or west, or not, yeah, let's do this. If it's east or west, or no, we'll just keep this with north or south. So we're gonna do like a turn right and a turn left. So union path p dot turn left. Dot turn right. Okay, that is looking good. Now we just need to do that for east and west. So this case, east and west is going to be turned left and right by this. And it's going to continue if it hits this. And I think that's all my cases. Doesn't matter yet how hot a thing gets. So I think this is our answer. So val ans1 equals path from point, not quite 0, 0. We're going to take point dot origin dot left that fires from the top left, okay. And then it's going to be firing, wait, let's call this west, and we're firing in the direction east. Okay, I don't care about that. We have a match error. /E. Oh, yes, we're missing the other slashes. Okay. East, west. So if it's slash in the other direction, just turn right, right? And if it's a slash in the other direction again, you just turn left. Okay, we still have a match error. We have a stack overflow. Are there that many points? Jeez. Or is it just an infinite loop? Let's test on the test input. Day 16, 2023. We'll save that as example. Okay, and we're still getting the Stack Overflow error. So let's take a look at our recursion condition. Let's see. Do drop one, take while area contains, so we won't go infinitely there. And then span mirrors that contains, right? So the first bit mirrors don't contain at all, which is energized, and continue starts with a mirror. Um, so then we take the next option from the continuation. You know what? Let's print that. P. Continue from P, yes. Going enter. And we'll do a print line here. Exactly that. Okay. Scroll past the Stack Overflow. What's our actual output? Oh my god. There we go. You know what? I think it's worth copy worksheet output. We're going to open up Scratch and browse this output. Okay. There might actually be infinite loops in here. Are there supposed to be infinite loops? Wait, like what happens in this case here? Oh, that's interesting. This case here, I need to think about that. Um, would have no energized path, but it would make a beam in this direction, which would that right there would infinite loop for me. Okay. But what is supposed to happen there? If a beam enters in the top left corner from the left, heading to the right, then its behavior depends on what it counters. Yeah. Continues in the same direction. It's reflected 90 degrees. The flat side, the beam is split into two beams. Beams do not interact with other beams. Scala can have many beams passing through it at the same time. Okay. We just want to know which tiles are energized. I think I'm just going to like remember what I passed over for now as a hack. Not a problem then. And we're going to prevent any repetition. So collection dot mutable dot yeah dot set, and this can be of point and direction. Point val scene, and then yeah, we're gonna pass that along. And it's gonna be set of point and dir. This is a little bit hacky, but it'll work. If scene, then set that empty about scene plus equals. Yes, and then all this stuff happens. Um, yep. Now all these recursive calls need to be updated. So we just pass scene into them. Or, I mean, does it need to be a parameter? I don't think it needs to be a parameter. Yeah, we can just close over it. Okay, so minimal edit. And this is the union of all these points. So it shouldn't be that big. Unless, oh, no, we never changed it to the example. 6164. Okay, let's change it to the example. I still don't know what happens in that corner case. Okay, I got 31 here. I can draw this. So we're gonna find area.draw. We're not gonna do it based on scene. We're just gonna do final equals path point dot origin dot west, and then we're gonna go on east. Call this last. ASP last P. Yeah, we're gonna do this. Maybe we put the mirrors first. Oh, wait, the mirrors are energized too. Oh, okay. Right, the mirrors are energized too. So we don't need to drop one. And we don't need to start from outside either. So this can just be point.origin, moving east. Wait, what happens now? 0.10 going east. It still starts. Okay. Let's go out west first. Now we get 0 because we're starting from our from point, which should be in the area. And then in the next set, we start from the point where the mirror is, right? Pa, 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 pa. Okay, so what happens now? Energize that. Continue. Okay, so the first bit of energize thing is 0, 0. That makes sense. And then we're going to continue from point 1, 0, going south. Oh, wait, going east. That should not go east. That should go south. Oh, no, we hit it going. Okay. So, so like moving dir into the mirror point. I guess we could put something beforehand. Well, yeah. Okay. So let's look at this again. Moving east into point 1, 0. Okay, that's a flat mirror. So now we have this energized set of empty that's like moving south into point 1, 0, 1 across and 0 down. Oh, because the first point is a mirror. Right, so we still sort of have to ignore that. I'm gonna go back to dropping one, and I'm just gonna add the mirror to the set. Yeah. Um, mirror hit equals new dot next option. I'm gonna add that to the energized set. We're just gonna do like a drop one, not drop one. And that means we still need to start outside of the boundary. Plus, 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 not to set. Sure, that will do. Um, yeah, sure, that's technically correct. Okay, and now what kind of error do we have? Key not found 0.20 across and 0. Moving east into 0.2001. Yeah, there's no mirror at that point. Oh, you know what's happened? It matters the order that I do this stuff. Okay. So we do return the energized set. I'm just going to add the P later. So we're not going to use this mirror's hit here. Yeah, plus P. We can fix this more later. I could have added P to this whole thing here. I've done whatever. Energized sets, just okay. So starting from the beginning, oh, we need to move west first. Here we go. So we start from and start moving in that direction, right? Drop the first one and take while air contains. So this should print line something. Def. What's going on? Oh wait, this looks correct. Area.draw. Yeah, this looks correct. So last dot size is 46. I'm just gonna do -1. Val as 1 equals whatever. -1. And we apply that to the real problem. Okay, that was an unfortunate sidetrack there. I didn't realize you had to count the mirrors too. But that looks better. 6815. 6815. Mm-hmm. Okay. Still slightly wrong. Perhaps for like similar reasons. So compute the path. I'm pretty confident about those directions. Let's look at that again. Day 16 example. And look at the drawing. So there are some leftover mirrors, sure. Otherwise, let's hide the dots since we can actually count. This looks correct. Okay. Let's not count it this way. Let's do like class dot filter area dot contains, or yeah, we'll just do a dot count. That should give us 45. That gives us 46. Is there an extra point in here somewhere I'm not seeing? Oh, it is 46. Oh, wait, so I didn't need to do the -1. I don't know why I thought it was 45, so I just add 1 and that's it. Okay. Oh my god. That's unfortunate. That's unfortunate. How are we doing here? A couple people are ahead of me. Okay, let's see what part 2 is. Um, there's a collection of buttons that lets you align the contraption so the beam enters from any edge tile and heading away from the edge. So the beam can start on any tile in the top row heading downward, any tile in the bottom row heading upward. Yes. Find a configuration that energizes the most tiles possible. Hmm. I mean, how long did it take me to compute this? Or I can just brute force that, right? Um, yeah, let's area that size. Area is 110 by 110. So multiply that by 10,000. Okay. 10,000 times 0.30. I mean, that's like a hard whatever. 3,000 seconds. You might want to do something more efficient, but we'll give it a shot. Hmm. Right, perhaps this is a case where like memoizing. Hmm. We're gonna need to like reset this mutable set every time we count. Uh, it is kind of a hack to stop early. I still don't completely understand like why this doesn't continue. I mean, I guess it does like continue. It goes off the edge and it just goes backwards. So like if it goes backwards, is it always gonna follow like exactly the same path? Yeah. Yes, anytime it's reflected. Maybe I could just head it off once when it's reflected backwards. When any path is like going backwards. Um, but preventing duplicates seems fine. Hmm. We'd have to add it as a parameter or just reset on each whatever. I think the fastest way to get to that code is going to be just to compute this for everything. So how do we do this? We do area dot left border dot points dot map. So scene equals set dot empty. Oh my god, don't let people see me doing mutation. And then we're gonna do like a path, and then we'll do the count. So given this point, path from P, I guess we move west under E dot size. And we get the sum of that. Yeah, so we do that one for all of them. Yeah, let's call this L. And then what do you want, like the minimum or the maximum? And then val r equals area dot right border maps point east. Okay, so val left top, val b dot border. Okay, that works. And then L dot max. I don't know, we'll put these into a list and just call another max on it. R dot max, top dot max, and bottom dot max dot max. Copy this over, reset it to, oh, wait. Not quite, we can't do that. So scene dot drop or delete. How do you move? Exclude. Clear. Okay, yeah. Scene dot clear. Yeah. Okay. Is this for the full problem? We could let that run in the background while we think about how to optimize this. um, no brute force. Oh, wait. Is that it? That works. 8163. 8163. There we go. Not bad. Not bad. Okay, how did I do today? I was. Wait, no, this is yesterday. And which leaderboard is this? This is my private leaderboard. I was fourth for part 1, 30 minutes. And delta time is 6 minutes to get fourth for part 2. Seems like everyone had a pretty small delta time. Gupta, Nikki, and Alexander. I don't know if you three are here, but well done, good job. Let's look at the Scala Center leaderboard. Okay, so how did we do? Day 16. I was also fourth on this one. Oh, barely right here. That's third for part 2, so I caught up. I think Benjamin there will be done any minute, and I'm ahead of Jan, who is my target to catch up to. But I think I'd like to widen that gap. So we'll try to do better. Third place finish there. I'm curious about the global leaderboard. So we'll look at my personal times. I wonder how I rank there. And for day 16, what were the times? 4 minutes for part 1. 15 minutes. Okay. And then for part 2, oh wait, for both parts together, right? Yeah. Wait, is this like 11 minutes for part 1? Okay, so 11 minutes to get on the leaderboard for part 1. Cool. I'm happier with my times this time. This is closer to what I was hoping for most of the year. I've had a few 5,000s, 3,000s. Okay. Great. Now I think I can do a little bit of cleanup here. This works. This thing here is kind of hacky. I don't know. Maybe I clean this up tomorrow and finish cleaning up 14. And we'll add 16. Commit that. 2023 day 16 as solved on stream. Yeah, let's go back to day 14 and fix whatever was going on there. So last I recall, we had an issue with moving west, and I was just doing some printing on that. So where's our tests? So we have a rock at 0.84, stable rock, moving 0. Okay, we don't care about that one. We have a rock at 0.1, -1, so this is from the top. And then 3. What direction are we moving? I don't know. I didn't say what direction we're moving. Oh, well, I mean, this is going to be west. Yeah. So we're moving west. Everyone move west from 0.1, -1. I think I need to filter out those cases. Okay, but I think that is so fine. It adds some negative points, but those aren't even going to be in the area. They're not going to be counted, and they're certainly not going to show up in this drawing, right? Where is it here? Oh, the drawing is all the way at the bottom. Yeah. The problem is what happened to all those other points. Um, we have this. So, like, what I did was take this whole outer boundary. Um, oh, crap. I accidentally stashed. Okay. Just looking at other stuff real quick here. Okay, so we're doing this moving count and set from. This looks good. So by -1. Oh, wait, west. Okay, we are ruling west. So we should be looking east of this thing, right? X minus moving count east of this rock to find the open space. And this is by -1. Is that right? No. Nope, that is plus. On the other screen here, I'm looking at my diffs, making sure things match. Then we're going west. Is plus moving count. X. I mean, this seems fine. X plus moving count. Map. Okay, let's look for another piece that might be more counterproductive. Um, and why don't we filter out empty areas? The area. Hmm. Um, yeah, if the area is empty, there's nothing to do, right? We'll just filter those out. If a that size equals 0, then we do nothing. We just return back. Else we do all this stuff. Okay, now this log here should be a little bit clearer. So that's north. North looks fine. West is weird for some reason. Maybe I should also filter out. Okay, so here x is 8 to 8, range is 5 to 9. Wait, why is the y range 5 to 9? The y range? We're moving west. The x range should have a range. The y range should just be one thing. There might be a problem here. Oh, I see. It's doing dir.south no matter what. So when I generalize this, I forgot to change that. Ah, okay, okay. Great. Well, we can clean this back up. 100% that's the problem. There we go. So we should be back to getting the right answer. So 136 is good. 64 is good. Yeah, let's go to the broader problem. And that still looks correct. What was it? Ooh, look at this. Our calendar's changing. We have a little bit of heat going on here. That's the light reflections, energized tiles. I haven't been following the story as closely as I should. Um, no, we're looking at day 14. Okay, making sure answers still match. 93102. Answers don't quite. Oh, wait, that's for part one. Answer 93102. Okay, that's good. Okay, great. So this cleans up then. Hashes, scene hashes. This is the repeat index, first index, a period, and then congruent. That works for me. We don't need this line here anymore. We don't need this. We want to keep cycles and loads and hashes. Let's put all of those. Actually, do we even need all the loads? Just calculate the loads. We just calculate the load or something. Yeah, we don't need to calculate all of these loads at all. So just say load of cycles congruent. Okay, answer doesn't change. In fact, that might even be faster because we're doing significantly less. I mean, we're just not doing a bunch of load calculations. Is there anything I want to show? I could show rounded, show rounded, and wait, roll all, rounded north. So that's like the part one. And these are like tests for part two. This. Um, Wait, this is looking better. I don't need any of that drawing code anymore. This first bit, I might change up a bit. So we don't need area dot width. Take the grid in the area. That's good. Um, I might express this differently. So this is the outer border is going to be this thing. This whole thing can just be called outer. Or, I don't know. Let's say this is expanded. And then just pull this out here. This fake point is going to be like set dot from all of this stuff. And real union fake. Set dot from. There we go. Yeah, that works. I wonder if we did like the full border. Now there are other ways to say this. We could do like area dot expanded dot diff. So expand one dot diff diff area. And then that gets us a list. So we're gonna like flatten it. I guess we like reduce, we can reduce that with, or rather we get the points. Map, we got a flat map. Flat map. So this is the outer border, val outer. Yeah, all the points that are outside. And we don't need to write all of that. The real union outer. I think it's just expand. There we go. Points. Greater. Okay, diff returns a list. I guess we'd have to set this. And are we still getting proper answers? 93102, yeah. Okay, that looks better. Open area. And this here, I still kind of want to make that generic. But there are 2 points. Can I do this in terms of direction? Part of the problem is like this area here. I want this memoized. I want this cached. But I could make open area a map. It's a function. Yeah, that's what I'm gonna do. Okay, so val open area. This is a map from a direction to a map of an area. Okay. And now we just take all of the directions. So Values dot map. There, you're trying to map from this. There is passed along. And this can go away. I suppose we need to do like a to that. What's the syntax error here? I hate this in syntax error so much because this means there's a syntax error somewhere else in here. It's just not a very helpful message. I guess that whole thing needs to be in a map not from anyway. Um, yeah, let's do that. So map.from, and we'll just put these parameters in here instead. And next issue, we're going to turn this into braces. Find what the actual syntax error is. Um, hmm. Can you not do that? What if we just said areas equals that? Now, third areas. Okay, it still has an issue with this. Expected fewer braces method body. But that is here. Oh, here, we expected a fewer braces method. Oh, I see. We're just missing an indent. Okay. A point for braces here. A point for braces. I couldn't see that. I don't know. I couldn't see that. Okay, that's a pain to debug. But now all these can be made more more generic. So open area. This map is essentially like a memorialized function now, right? So we just pass along the direction. Yeah, and now this whole first part is the same. And we'll just check that answer is still correct. Area. Ambiguous overload. The types map aoc.dir to both of them mismatch. What could that overload possibly be? Yeah, let's just apply. I guess we do that then. Yeah, I know the feeling. I only got sub 1K like yesterday. Last year I got sub 1K 5 times, and I was hoping I'd be better about it this year. Did you just finish? 2000. So today I was around like 1200-ish. Let me see. Oh, 1500 for the first part, and I caught up a little bit on the delta. Mine wasn't efficient enough. I was just able to sort of like brute force it. Um, and right now I'm trying to like clean up my day 14 a bit. It's been going well. I'm almost like deduping all of this stuff. Now, like the first four lines of all of these are the same. So we can move the dir.match lower, I guess. So let's start with this. And now here we do dir match. Let's do the exhaustive match. And we can just copy those lines. So here is for east. Here is for north. I'm not sure exactly how to make that generic on point without like adding stuff to my library. Here's from west. And here's from south. Okay, that's looking much nicer. You calculate the open areas. We don't need this open area function anymore. Well, I suppose I could have used that. Um, yes, this works. Do I need to say the set that? What are these points? Um, I'm starting to like the set that from method. So I like move this down, move those forward, and then set that from. I suppose I have to give it. I'm gonna do it that way, or maybe not. Maybe not. Let's see. Yeah, that still works. Um, yeah, that works. That works. And here's all like my cycle calculation. What are these points it's going for? Oh, load. Where points? Yeah, points are a set, so I take the iterator, map some. All right, and this is just test stuff here. Oh, wait. Our answer changed. Our answer changed. We're not getting the right answers anymore. What did I change most recently? Did it happen after this? Or did it happen after this? Um, I don't know. That's the problem. I did this set from thing. Okay, back to looking at some of our tests then. Go back to the example. This is why you should check your tests as you're going. That doesn't look correct. So it looks like some rocks have rolled off altogether. And let's show the size of that. Like this should be 18. And oh, it is 18. I don't count 18. 1, 2, 3, 4, 5, 6, 7, 8. So did some of those points go too far north? Okay, let's do this. Let's count area that contains 8. So 10 of them rolled off. So I'm going to look at where those went. So we could do like a filter not, area that contains, and then for each print line. These are points that rolled off. And it seems, where exactly have they rolled? They've rolled off the bottom. Interesting. That happened while I was doing. Okay, let's think about these. I'm just gonna put this in the order I usually have it. Okay, so north s dot y to p dot y. Um, plus moving count. So these are points to the south. Let's add in some assertions here. So assert um, a dot width is 1, right? Assert. Well, yeah, let's start with that. No assertion errors. So we're at least in the right direction. What's getting moved? So like these are the new points. A that points to sit right. You know, we only need this 2 set here. Right, you can just count. How many are in the starting location? And I am I've been like debugging. I've debugged this a few times while I've been refactoring it. I don't know what the last change I made was, so it's probably, I'm guessing it's probably not in, well, okay, we directly tested roll all. But what else changed? You could look at open area. So open area, north, and then we're gonna filter the ones that actually have some area. Um, so the size of the area, that size is greater than 0. Okay, so like a point like 310, the area is range 3, 3 up until 4, 9. 3, 3 is too much. Oh wait, no. 3. This is rolling north. 3, 3 is the width. The range goes from 4 to 9. Right, and that looks good. So we have, that was 310. So across 3, down 10. That's here at the bottom border. And we have 3 until 9. That seems wrong. Okay, let's look at some of these one by one then. We'll do like a for each line so this is more visible. Okay, so the 810, for example. This is off the bottom boundary, so this is like a virtual piece. 8 across, 10 down. And how wide is this? I think this is also 10 wide. So the points should be range 8 to 8, and then 5 to 9. So this is 5, 6, 7, 8, 9. That looks good. Oh, I wish I had tests for this. south. Look at one of these. 8 across and 4 down. So this is going to be the area south of that. 8 across and 4 down. That's going to be 5 to 9 again. Oh, that's curious. 8 across and 4 down. 4, 5, 6, 7, 8 across. 0, 1, 2, 3, 4. That's not even a rock, is it? Um, so this is a square point of some sort. X and Y, so 8 across and 4 down. 0, 1, 0, 1, 2, 3, 4. Maybe this is 8 across. This is 8 across. Okay, in that case, we have the range 5 to 9. So that's the area to the south. 5, 6, 7, 8, 9. Yeah, so that's the opposite of the other one we just checked, right? But we know rule north is not working. Why don't we juxtapose? So we're going to juxtapose this with the area. So I'm going to do print line, say, placing these in that area. And do we have another print line we want to get rid of? Okay. Now let's look at our roll north. Placing, oh, I misspelled placing. Okay, we should only print this when it's sort of relevant. 6, 9 in area. Okay, and then in the actual roll off, I'm going to copy worksheet output. So where is it? Roll all north. Okay, so some points were rolled too far. Say the points in the first column. So let's look for a point that's in the first column, like these. Nice, True Winkle. You're still dwelling on puzzle day 5. Have you finished part 1 of that puzzle? I remember having an issue with part 2. I won't spoil it for you if you don't want me to. So 0, 9, 0, 10, 0, 11, 0, 12. Those are some weird points. Wait, you have the answer already? Oh, so you're just like thinking about it. So you have the stars. What are your thoughts on day 5? So what's happening here? Here are all these zeros. We're looking at the stuff that got rolled north, right? So this stuff right here, some of them apparently didn't hit a rock. And you got points 0, 9, 0, 10, 0, 11, 0, 12. In area range 0, 0, so column 0, and 0 to 7. 0, 1, 2, 3, 4, 5, 6, 7. It's in that whole range. So how they don't end up there, well, it's because we got 0, 9, 0, 10, 0, 11, 0, 12. Those are south. Those are not north. I see what's happening here. Um, we must have flipped our south and north while we were factoring. So the north space, p dot s dot y. Okay, so when we're rolling north, this is the direction we are rolling. Then we have the area to the south of that point, right? Yeah, we have the area to the south of that point. And we take its y value. Oh, yeah, these are a bunch of rocks below. So the points that were moving, what points did I have moving? Here, placing this vector in that range. But they don't match. Oh, okay, I know what it is. So if we're rolling north, then we want the open area to the south. So this can be that reverse right here. That fixes things. I see. I see where we. Oops. Okay, so generally looking a lot cleaner. It's still like not the shortest, but it's legible. And I'm happy with people reading this. I should have my code larger. I don't know why it's been so tiny. Okay, we will commit that cleanup. And we'll probably call it a night here. Look for someone to raid. Someone's still working on today's problem. So cleanup. Cleanup 2023 day 14. This is actually more than a cleanup. It's a cleanup and a factor. Push that. Okay. So that has been pushed up here. It got a little complex trying to get the answer faster than 160 seconds. I see. Yeah, so day 5. I won't try to spoil you. I just want to remember what the issue was. Oh, yes, yes. You, you have very large ranges of seeds, and you don't want to have gigantic arrays of positions of seeds. That makes it difficult. This was a fun one. I like this one. What's this code? This one right here is my day 5 solution. Oh wait, oh the code I just no the code that I just showed on stream. That was my AOC leaderboard. I meant to show my GitHub account in case anyone wants to look at what I have. I think the range fills the entire 32-bit range. Yeah, yeah. You don't want to be filling any like vectors or collections with that. So if your language has a range type, you want to use that instead. Okay, this is good. Let's find someone to raid. Who's on registering admin code tonight? You see the benefits of Scala? What exactly are you seeing? You mean like in that range type? It tends towards like functional concise code, and I like that about it. Uh, I really like the type safety of Scala, or the type system and what you can do with it in general. Yeah, natural use of a range type. So Scala does have a built-in range type. Um, I made my own for this. I use for admin code because I'd like a few more features, and that's somewhere in this repo. Oh, whoops, this is the wrong day 5. Uh, so this thing here I'm calling interval, and the reason is like I want to do like set intersection type things. So like, what's the intersection of two ranges? And if you do that with normal Scala ranges, what it outputs is now an array of numbers instead of just a range. And I want ranges. How'd I get into Scala? NIH syndrome. You have to remind me what NIH is. But I got to Scala. I don't know. I just into languages in general at the time. I was exploring a lot of languages. This is about a decade ago. And I was into functional programming. I used um, Java and Python and Scheme, and it seemed like the best of all not invented here syndrome. Yes, like somewhat, except in this case, it's I think it's actually applicable because the range type just isn't isn't suitable. There are so other people have implemented range types like this. There is some of this stuff in library code, but for admin code, I want to stick to the Scala standard library and stuff I've written. So I didn't want to import that. So I made my own, and it was a fun exercise. Um, I want to learn a language with more functional support, Kotlin or Scala. So Kotlin, in some cases, is like anti-functional. Kotlin is a great productive language. Um, it has good integration with Java. Coming from Java, it'll be a lot easier to use. You could use it for Android development, etc. One thing like Kotlin is missing is pattern matching. Like Python 3 has pattern matching now. JavaScript has pattern matching that Kotlin doesn't have. They're like switch case or something. If you want to learn functional, if your goal is because you're learning functional programming, I would go with Scala because it's still gonna seem familiar to a Java dev. Of course, the stuff here I'm writing looks more like Python, but like traditionally, it looks more like Java style syntax with the braces and whatnot. So Scala will be approachable. Haskell will be a little bit more foreign, but like Scala borrows a lot of stuff from Haskell. But I'd go with Scala if you want to do it just to like learn new ideas and whatnot. And Scala is also like a great language to use for industry. You know, the salaries are good, uh, and there's a lot of interesting stuff happening in both its ecosystem and community. Oh, who's this? Juicebox. Is Juicebox working on the splitter problem? Okay, and you know what, Alka? If Alka's working on this, maybe we raid them. Oh, wait, did they just solve it? Oh, they're just trying to like performance optimize it. I think we, I think we raid Alka anyway. Um, you like Alka over here. Oh, and VP Punk, thank you for the follow. Oh, an A6400. I missed you earlier. Thank you for that. Okay, good luck, everyone, with the rest of your admin code. Have a good night.